Hello, my name is Hannah Eberens, and I will be reviewing the Rainbow Connection science experiment. So first you need to know what an acid is. So the definition is a chemical substance that neutralizes alkalis, dissolves the metals, and turns litmus paper red, typically a corrosive or sour-tasting liquid of this kind. There are three different types of acids, including the Arrhenius acid, Bronsted-Lowry acid, and Lewis acid. Some examples are lemon juice, which is citric acid, vinegar, which is acetic acid, stomach acid, and soda pop, which is carbonic acid. Next, you need to know what a base is. The definition of a base is a chemical species that donates electrons, accepts protons, or releases hydroxide ions in aqueous solution. There are three types of bases as well, including Arrhenius bases, Bronsted-Lowry bases, and Lewis bases. Examples include alkali metal hydroxides, alkaline earth metal hydroxides, and soap. So in acid-base chemistry, there are three types of theories. The first theory is the Arrhenius theory of acids and bases. In this theory, acids are substances which produce hydrogen ions in solution, and bases are substances which produce hydroxide ions in solution. In the Bronsted-Lowry theory of acids and bases, an acid is a proton, or hydrogen donor, and a base is a proton or hydrogen ion acceptor. In the Lewis theory, an acid acts as an electron pair acceptor, while a base acts as an electron pair donor. In the following video, you'll be able to see a visual example of these different theories. So in the video, acids and bases are mixed to show and remove the different colors of the rainbow. An acid-base indicator is already present in the beakers before the video starts. This indicator includes thymolphthalene, phenolphthalein, and paranitrophenol. A little bit of sulfuric acid and ethanol solution is added to the beakers before the video starts as well. This allows an acid to be present, to be mixed with the base, and the ethanol allows dissolving of the indicator so that the mixture changes colors. You see the chemist adding a clear liquid into the beakers and colors appearing. This clear liquid is a base that allows the mixture's pH to rise above the equivalence point, which then turns the mixture to a different color based on what indicator is in the beaker. Then a dropper is added to each beaker, which contains sulfuric acid and a glycerin mixture. This mixture lowers the pH and makes the color disappear. The reason it takes so long and needs agitation is because the glycerin slows the color change. This process is repeated later in the video if you continue to watch, where the base is added again, rising the equivalence point, rising the pH, allowing the color to appear, and then adding an acid back into the mixture, which lowers the equivalence point, lowers the pH, and makes the color disappear. Some final thoughts. This is a great example of acid-base chemistry because it displays the acception and donation of protons and electrons visually. You can see the donation of protons exchanged through the color change and the exception of protons through the color disappearance. The magic of the experiment leaves viewers wanting more and wanting to learn more about acid-base chemistry, which is always a great thing. Thank you.